So you guys should be able to see my screen now. Looks good. So, like I said, we're going to talk about doing on-demand compute analytics with Hadoop, and we are going to do it in Azure. Azure is the cloud platform that we prefer as a Microsoft partner, and as a company that's totally lined up with the Microsoft data ecosystem. It doesn't mean we can't do this in other cloud platforms, and we do. We have other customers who run in different infrastructure as a service offerings, whether it's AWS, whether it's Rackspace, whoever. So a lot of these things will, a lot of the concepts will be similar, but the implementation and the simplicity of the implementation here specifically is really because of the fact that we're doing this in Azure and we're using Microsoft's HD Insight capabilities. So we'll get into some of the technical sides of that here in a little bit. The first thing I want to talk about is, I'm not going to do the whole what is big data and why is it changing the world and all of these types of things, because ultimately big data is not going to change the world. I know that might be controversial to say, but big data is essentially a group of platforms. And when we talk about the business and technical case for big data, I think the pointy-haired boss has it right. Using it is really the hardest part, and because it is a platform and it's a bunch of disparate tools, and really the hardest part about learning it, and some of you who said you've got intermediate level skills probably have already run into these challenges, is pulling it all together, right? There's 400 different individual little open source products that when brought together kind of like an orchestra will make beautiful data music. But if they're being played like a fifth grade band, like most of us know how to play them, it's just sort of painful to watch and painful to listen to. So, we need to be able to, really understand the fundamental concepts behind big data and what's driving it and what we're trying to accomplish, and then work our way into, building out those types of solutions. And so we'll talk a little bit about the fundamental concepts today. We'll talk about the cloud's impact on those types of concepts and what that means. We'll talk a little bit about the deployment models and why, how we get to an on-demand scenario, and then I'll deploy one for you. We'll talk a little bit through some of the PowerShell and automation to be able to do that. So we'll flip over to a demo here in just a couple minutes. I promise I'm not going to keep you guys in PowerPoint the whole time. So when we talk about fundamental concepts behind big data, what's driving it? Well, what's driving it is the fact that everybody thinks that, like I said before, that it's going to change the world. So the driver is really probably 30%, 40% hype, and 70% reality. It is a new platform found, based on the Hadoop, the Hadoop product, which is really a distributed computing platform, is really the best way to phrase it. It allows us to do distributed processing, distributed file system, distributed storage. Originally deployed to run on a Linux and Unix environment, ported to run on Windows, and now it's deployed in the cloud. And that's really where it's starting to see the most traction, because a lot of folks don't really want to go invest a huge amount of money in a ton of blades. So deploying Hadoop can come across as, oh, it's cheap, I'll just use these leftover machines I have laying around. I got news for you. If you've got leftover machines laying around, they're probably not great for big data either. So we'll talk a little bit about the deployment models in cloud in a little bit, but the changing characteristics of data is really the biggest driver. We want to start making decisions that are more and more data-driven, but not just one or two dimensionally. The biggest thing that we can accomplish with these types of technologies is adding more and more dimensionality to the decisions that we're making, and the way that we do that are through things like fixing our signal to noise ratio, getting a lot better correlation and causation analysis and discussions and those types of things. And right now you're saying, oh, he's using statistics words and data science words. I'm not a data scientist. Most people are not data scientists, right? And so what we're going to talk about today is just how to get a good platform up and running to be able to interact with Hadoop in the cloud and to be able to do your analytics in the cloud in an agile way, right? And those analytics requirements really come from operational optimization. How can we be a better company? How can our manufacturing work better? How can our drivers and delivery folks and our air traffic controllers and any number of different industries, how can they be more efficient? Well, skip the slide. How do we get actionable intelligence? How do we make sure that the data that we're getting drives real decisions, and how can we even potentially automate that? And how do we identify new markets? How do we look at the products that we have and the things that we're building and really figure out if we can understand some of these new customers and try to figure out what our customers would like for us to be able to deploy.
Hey, Adam, sorry to cut you off.
Yes.
Your screen's kind of cut off. I don't know if you can fix that.
I can sure try. Give me 1 second here, guys. Apologies for that. Give me 1 second here, guys. I apologize. Not sure what's causing it, but I'm going to play with my video settings here for a second, see if we can shrink it down a little bit.
There you go.
Is that better?
Yep, perfect.
Okay. Okay, great. All right. Sorry about that, folks. We will keep going. So we're also talking about new markets, right? So from a customer perspective, we want to understand what opportunities do we have to go and identify new customers that are interested in our products, but also want us to be able to do different things. So we can identify those with better data analysis. We want to make more accurate predictions and be able to dive in and look at fault and fraud detection and all of these different areas to really analyze our business and begin to add value. It's been a long time since IT was really considered a value-adding organization. A lot of executives look at it more of a cost factor, expense, that type of thing. With the capabilities of a more efficient distributed platform that is cost-effective and highly performing, we have the capability to start adding a lot of dollar value back into the business through better analysis and better analysis platforms. And it's incumbent on us to be able to take advantage of some of those opportunities. We also talk about things like decision science and scientific discoveries. I had a client the other day tell me, well, we don't really do scientific discoveries. They said, I said, aren't you guys an oil and gas company? They said, yeah. I said, you guys do scientific discoveries all the time. You just might not do it in your part of the office. Let's think a little bit bigger, right? Think about all the things that your companies do and where you can add value, even if it's not in the little area where you would tend to work or the people you tend to interact with day to day. So your typical components of a big data ecosystem, now some of you guys may have seen a different version of this slide that's got about 47 boxes. I took all those out because, one, we're not going to use them today, and we're not even going to use all these today. And two, most of you are not going to use all of them ever. Most big data ecosystems don't use all of those boxes. They use a few, and they get started and they continue to roll and add additional capability. From a operating system platform, we can run it on Linux or Windows, Amazon or Azure or Rackspace or others. And we can run it on-premise or in cloud. These are the important questions that you need to be asking as you're thinking about doing a deployment. On-premise has some real benefits. So you can walk in and touch the server and cuddle with it, at night if you're cold. It'll keep you warm. Other than that, not a lot of benefit. Even for folks with very secure data, Microsoft's cloud has government on-ramp programs and other things like that for very, very, very secure data that's very, very private. If you need to keep the data on-prem, then there are good on-premise deployment options. But the storage flexibility is a little bit different, and there's a lot of challenges around expansion and really being on demand, right? So, you may be able to spin up, if you have a very advanced private cloud scenario, you may be able to spin up Hadoop clusters on demand and virtual blades and that type of thing, but typically implementing that is really complicated, very expensive, and it's going to need full-time administration. And you're still going to be back-ended by SAN storage and other things that are less than scalable and really don't give you any financial or budgetary advantage for your bosses. At the end of the day, you're still in that capital expenditure mode instead of that operational expenditure mode, which is really what one of the things that the cloud is going to be able to help with. So the components that we've got on this particular slide, if you look down toward the bottom, we've got HDFS. That's Hadoop's distributed file system. That's just like NTFS, except that it can manage files distributed across different machines. So think of it like a clusterable file system. MapReduce, that's our distributed processing. There's now a new revision, if you want to think of it that way, of MapReduce called Yarn. Yes, the thing your cat plays with and your grandmother knits with, Yarn. With those two things really work together. Yarn has the capability of running certain types of jobs without creating a MapReduce job. A MapReduce job has some overhead to it. So for very small tasks, you don't really want to create a MapReduce job because it's going to run slower. But for the larger tasks, that overhead is well worth it to get the distributed performance that MapReduce can provide. HCatalog is our managed metadata service. So it keeps track of all of our tables in Hive, HBase, our relational style stores, and our columnar stores as well. And by doing that, it allows Pig and Hive and all of those tools to all know the metadata for all those different objects across any different job that we're running. And so that's a very important component to be able to use. Otherwise, if you just create a table in Hive and you try to access it with Pig, it'll just be like it's in two different SQL servers, right, that don't talk to each other. It's not going to have any idea what you're talking about. What is this Pig and Hive I'm talking about? Well, Pig is a data flow scripting language, so a lot of people use it to do data cleanup, data cleansing, data organization, grouping, sorting, filtering, regex work. Think of it kind of like a little bit of a replacement for your ETL, right? So it doesn't necessarily replace your ETL, but you may need to run some Pig against some of these files in order to get them to a place where your regular ETL can really pick it up and absorb it and consume it. Hive allows us to put some relational structures, either logical or physical, around that data once it's somewhat organized. It can be JSON data. It doesn't have to be tabular data. It can be JSON, XML, any number of different formats, as long as you have what's called a SER day, serializer deserializer, which is a program for Hive that basically just tells it, hey, when you interpret this table, here's my data format, and here's how you interpret it. And there are a lot of public SER days that are available for very many common data types. Hive supports a few right out of the box. Or if you're really adventurous, you can write your own in Java. If you have a custom data type that you want to leverage from your organization, you don't want to have to convert it to something else. We also have HBase. HBase is our non-relational database, primarily focused on columnar structures to get us a lot better performance and compression for larger data sets that we need to put a semi-relational or columnar structure around. We've also got some other projects, things like Embari, Avro, Cassandra, Uzi, Zookeeper. All of these things do different individual tasks within the big data system. They're out of scope for us today, so I'm not going to go through all of them. There are a lot more than that. I think there's almost 50 in the Apache sub-project at this point, all of them at different levels of maturity. So feel free to go out to Apache, apache.org, and take a look and go through all of the different Apache projects and really read up on them if you'd like to. We've also got analytic products, not so much in the Hadoop Apache project per se, but we have analytic products like Power BI and Tableau and others that we do a lot of really amazing work, frankly, for customers that really helping to visualize their data. The ability to bring cloud data into Power BI is an incredibly powerful story, and it's a lot easier, frankly, than trying to move data back and forth amongst 3 or 4 different systems. So from an analytic product perspective, we can consume this data with a variety of different tools and in a variety of different ways, making the end user experience really, really solid. And that's really the key for things like adoption, right? We need to get the solution adopted in order to make sure that that folks are really understanding it, really getting a lot of value out of it, and really feeling like they're really getting the best out of this type of analytic platform. For visualization and analysis, same kind of thing, right? We're really focused on trying to make sure that for the marketing folks that are creating things like infographics and public-facing statistics that we've got, easily consumable data, and we do. For folks that are looking to do more in-depth statistical analysis and iterative analysis, we've got that ability to access those things as well. Most of these tools can all be, wherever your data is at rest, can be accessed through REST APIs, ODBC drivers from all the major vendors, and so there's a very industry standard approach to being able to attack some of these things. Okay? So now let's talk about the cloud, all right? So now we understand why we care about big data. We understand what the components are in that ecosystem. Now let's talk about why the cloud is such a big deal. And, again, we're doing our deployments in Microsoft's Azure cloud because, frankly, the nice thing about being an independent company is we get to pick the product in the cloud and all of those things that really work the best for us. And in our testing, we've picked Azure. And so that's one of the reasons that you'll see us talk about that very, very often. The cloud's impact to big data, all these things on the sheet right here, you don't need me to read them to you, but easier adoption. I had a customer the other day that we were talking to, and they said, well, why, we're not really cloud ready, right? And I said, look, I think that's a bit of a misnomer as far as, not being cloud ready. Every company is essentially cloud ready. If you have a credit card and you have a workload that you'd like to stop running in your data center all the time and stop paying for it, we can take that and we can move it up to the cloud. It's very easy to get going. You don't need a big infrastructure design meeting. You just need to log in and set up a machine and move some data. It's actually pretty straightforward. Now, for bigger implementations, of course, you want to put more thought into it than that. But as far as adoption goes, you don't have to go through necessarily the full budget cycle. You don't have to worry about allocating depreciation for machines and all of those types of things. Time to value. If we can get something up and running quickly, we're talking about on-demand compute today, right? So the whole point in doing on-demand compute is being able to get something up and running when you need it and then let it go away when you don't. That's really important. Financial flexibility. We kind of already talked about that. Scalability and elasticity. One of the things that I'll show you when we deploy this cluster is I just pick the number of nodes that I want. And so if I decide tomorrow that I need double the number of nodes, I don't have to go to my infrastructure team and say, oh, guys, you're never going to believe this, but we have this big project we need to run, and now I need double the servers or it's never going to finish. Or I have to do the opposite, and I have to go tell my boss, hey, we didn't plan for enough servers, and so it's going to take 3 weeks to finish this job instead of 3 days. And he or she is not going to be too pleased with me. Deployment model flexibility. We have the ability to combine on-premise data with cloud data, with third-party partner data, so maybe we get feeds from marketing partners or sales data or from our CRM. We have the ability to combine all of that without a complex ETL process necessarily pulling all of those things together. Or we can leverage our existing mature ETL process and make the cloud storage another destination and be able to use the data in two places, which is not a bad thing when the cloud storage is as cheap as it is. Of course, we talked about storage cost and integration, but the thing that I like the most about being able to deploy this in the cloud is the second to last one, which is metadata persistence. And that may not sound very exciting, but here's why that's exciting. In an on-premise Hadoop implementation, you have a couple of components. So you have Hadoop, which is encompassed of, if you remember, it's got our HDFS and our MapReduce. And then we've also got HCatalog. Well, HCatalog is going to store all that metadata in a database somewhere, right? So we have to give it a database. Now, typically it would use a Derby database, which is Hadoop's own internal default database. But I don't like that in the cloud. I would rather put it somewhere where I know multiple people can access it. So what I know in the cloud is I know I have my storage separate from my individual machines, so I can get rid of a machine, a particular cluster, and my storage account with all my data is still sitting out there, unless I decide to delete it for some reason, but I wouldn't do that. I'd leave it out there. In addition to that, that metadata database, which says, hey, this Hive table called customers, which points to this directory in my Azure storage with all these files with all my customer data, that whole connection is still there. So not only can I get rid of my cluster and still keep all my metadata, and it's all there the next time I boot up and connect that cluster to that Metastore database, but I can have multiple teams now all sharing that same metadata store, and everybody can benefit from the work that my team is doing, and we can benefit from the work that my counterpart's team is doing, and so on and so forth. So it creates this very collaborative environment where if you were on premise, number one, you can't shut the machines down because the local nature of the storage would mean you would lose some data. A cluster could become corrupted. In the cloud, all of that is abstracted from the actual cluster. It just is more of a logical connection. All of that's in the same data center, so it's still very fast and high performing. Sorry guys, I muted you for a second. I thought I was going to have to sneeze. Apologies. And because it's all in the same data center, we get really, really great performance. And so that'll make a little bit more sense as we go to deploy it, and I'll show you the script and how we build things. But the key to building an on-demand system is being able to keep all the work that you have done and keep it valuable while still enabling you to only pay for the compute when you're actually using it, which is what the cloud really drives and adds value for. I put this little slide together here just to talk about a typical big data solution. So for those of you who are really new to big data, typically you're going to follow a process something like this. So we'll start with initialization. We'll go initialize our cluster, make sure we manage our storage, make sure it's connected, and make sure we have our Azure SQL database that's going to store all of our metadata, right? So now that's our basic process. Next, we're going to load. So we're going to go get our source data wherever it is. Could be some free public data. Could be some data that's generated from our CRM system. Could be any number of different things. And we're going to upload that data. We're going to pre-process it, maybe with Pig. Like we talked about a little bit earlier. We may need to pre-process some of that data with a little bit of Pig script. Pig is not a complicated language. If you get a chance after the webinar, feel free to go out and hit the interwebs and check it out. If you can communicate a process like I want to sort this data on this field, you can do Pig. It's actually very similar to SQL in a lot of ways, even though it's not exactly the same, but it's pretty easy to pick up. We're going to load that data into Azure Storage, which is going to also load that data into HDFS. And then if we want to, we might load that data into something like HBase. If we have a lot of data that would benefit from a columnar structure, maybe we take it a step further and put it into HBase. But we don't need to. Just as long as that data is in HDFS, it becomes accessible through a table in HCatalog, through a Power BI ODBC connection, through a third-party REST API that we might want to call from a .NET application or a Java application. We've got all different types of ways to access that data. Then we're going to query it, transform our data, actually start using it. Then we'll access the results and pull those down and do some analysis. And then we'll evaluate whether that worked or not, right? Did we get the answers we thought we were going to get? Did we get answers that are valuable? If we did get those, then great. If we didn't, then maybe we need to go back to the query step or the load step and maybe load different data or structure it differently. This is not that much different than when you first build something like a data warehouse or a data mart. You load your data, you look at the data model, and we take a look at really what kinds of questions we're going to be able to answer based on the model that we've created. And so we're going to do basically the same thing. Based on the data that we've collected and the queries we ran, does that give us the answers to the types of questions that we're looking for? And if it does, then let's transfer those results out to a visualization tool. Maybe we push some of those results down to our enterprise data warehouse to persist them now that we know we have good answers. And then we can monitor and clean up the solution. So this entire process can be automated pretty easily with PowerShell to run every night, almost like your ETL does, or even multiple times during the day, to spin up your cluster, load your data, execute the queries that you know are important, extract that data, and then push that data down to an EDW or out to departmental data marts or even down to Power Pivot or tabular workbooks, things like that. The last thing we can do is we can clean up that cluster. We can just remove it and get rid of it, which is pretty exciting. And we don't have to keep paying for it. But what we don't have to do, because you'll notice it's a different step. You'll notice, whoops, sorry guys, I wanted a pen. You'll notice here, this is a different step than clean up storage and clean up SQL database. So if we don't clean up the storage in the SQL database, if we leave that, next time I come around and I initialize my cluster, I can just connect to storage and a Metastore database that already exists. And that's very, very powerful because now I don't lose. That allows me to keep all of this work that I did. And I can just spin up the compute on demand every 3 hours, overnight, whatever it is, and be able to run the same queries over new data plus the data that I already have, continue to get value, and continue to monitor my solution. All right. Now the next couple of slides I think are going to be very interesting for those of you who are a little bit newer. It just covers a couple of common big data solution workloads. Once we get through those, we'll jump over and we'll take a look at the PowerShell demo. We'll run through that. All right. These shouldn't really take too long. So use case 1 is all about iterative exploration. So we want to put some data into HT Insight. We want to process it. We want to get some results. Doing that is very, very easy to do. We just finished up doing a pre-con out at SQLBits over in the UK, and we're going to be doing one at Past Summit as well. If you guys are going to Past Summit, you may want to check it out. This is a very small component of that pre-con, but we actually walk through these iterations and show how we get data in, process it, get the results out, and build the cluster, tear it down, do all of it soup to nuts in about 30 minutes. So it can become a very agile process, one that a lot of folks are using Hadoop and these types of tools to be able to do. It's, again, iterative exploration. Do I think I get this value out of my data or not, without having to build an ETL and put it in a tabular structure and process it all into my data warehouse and go through all of that. Use case 2 is data warehousing on demand. So folks may want to take it a step further and say, I really just need my data warehouse and my data structures to process into my analysis tools. I don't necessarily need them as an EDW. And I can store all my data in the cloud for a lot cheaper than that EMC SAN or the VMAX that I've got behind the curtain. Those kinds of things are really pricey. So if I just put my data in the cloud, I can process it in overnight and then only output the data that I care about. Remember, ingesting data into Azure in the cloud is generally free. It certainly is for Azure. Data egress, bringing data out, is where you get a little bit of a charge. So if you're only bringing out the data that you really need, you really can ultimately save a lot of money over time. So a lot of customers are getting a lot of value out of a use case like this. The third one is around ETL automation. So most folks, as soon as they begin to see value in their data beyond just their enterprise data, they want to add that data and the processing of that data back into their overnight ETL or their automated process that loads data into their enterprise data warehouse or an Azure SQL database for reporting or another application or reporting solution. And the best way to do that is with some of the automation that we're going to do today with PowerShell, and then extracting that data is very, very easy from HT Insight. We can use, again, Power BI automation, or we can use SSIS, or we can use, again, I think I mentioned PowerShell before, or we can even use Python or other tools like that. We're not going to get into some of those other tools today. I don't want to make this too confusing. But there is a lot of great ways that we can tie this back into your ETL. The fourth use case that I really want to talk about, and the last one, is just BI integration, right? That's really what it comes down to. And the whole concept behind BI integration is just taking that ETL automation one step further, right? Which is, getting your input, processing it, pushing the results out into your ETL, and to maybe a corporate level data model, and to your report level integration. So you may have all of those different tools connecting directly back to your cloud storage to access that data. All right. So now that we've talked about why we care about big data, what are the components, how do we deploy it, and why does the cloud matter? Let's talk a little bit about what your deployment models really should look like. So common deployment scenarios, you might have a personal deployment just on your laptop, a development deployment, production. Then we'll have deployment automation, which is the one we're going to focus on primarily today. Then extending capacity. So like we talked about before, I've got 16 nodes. I just figured out I really need 24. How do I go about doing that? And then maybe we'll talk. I'll mention some common challenges and some little things that we ran into as we were building these things out to try to save you some time as you're going through this and maybe banging your head against the wall for the first time. So preparing for your deployment, in order to do everything I'm doing today, you'll need an Azure account. You can use a trial, free 30-day trial, that's fine. You can tell I borrowed this slide from my pre-con deck because there's a pre-con pack that we give to all of our pre-con attendees that has all the scripts for the rest of the day, which aren't really in scope for today. You guys will see the script that we're talking about today. You'll need your Azure PowerShell commandlets. And then the Hadoop.NET SDK is helpful, as well as the HD Insight emulator and the Azure Storage emulator. The Azure Storage and HD Insight emulator would allow you to do everything we're going to do in the cloud right on your laptop. So if you didn't have internet connection, you could still run these things, and it would look and act and feel just like Azure when it comes to the PowerShell commands. In addition, in our pre-con, we actually have a little tool called the PragmaticWorks Social Media Exporter, which allows us to dump all of your social media data. You log in, you do it yourself. It's just a little app that you can connect to your Twitter account and your Facebook and LinkedIn, and then we use your data as kind of a lab experiment for the rest of the day. But we're not going to get to that today, so you don't need to worry about that if you're going to try to replicate today's work. All right. Whoops. So the personal setup, if you're going to have it on your laptop, which I just wanted to make sure we highlighted for you guys, especially for you beginners, you want to go get the HD Insight emulator. That's basically going to give you Hortonworks Data Platform for Windows, and it's going to download and you'll be able to run it there locally on your Windows machine. And the Azure Storage Explorer. The Azure Storage Explorer is part of the Azure Storage SDK, software development kit, and that will be, once you download that, you should be in good shape. If you want to use Visual Studio to access any of those Azure Storage emulator functionality, you're going to need the Hadoop.NET SDK. If you're just going to use PowerShell, then you'll need the Azure PowerShell commandlets, one or the other. So let's go build it together here in just a minute. That's what we're going to jump into here for our very next demo, which is right after this slide. The last setup is deployment and production team. Typically, we have HD Insight deployed through the Azure portal, or we have HDP, which stands for Hortonworks Data Platform. Hortonworks is another major vendor that sells Hadoop products, and they're a big partner of Microsoft. So Microsoft's Azure implementation of Hadoop is largely based on Hortonworks product, and so there's a lot of very easy overlap, very easy portability between the two. So for development and production, we deploy through the Azure portal, or we deploy with PowerShell and Windows Azure SQL Database. Usually we're using multiple storage accounts to keep people's data separate and those types of things. Linux or Windows, we could, HD Insight is a managed service, so it runs on Windows behind the scenes. We've never had an issue with that. But you may want to deploy it. I have it down there where I say deploy in Azure IaaS. That stands for Infrastructure as a Service. Infrastructure as a Service is basically hosted VMs, if you want to think of it that way, along with the fabric and everything that manages all of those. So you can do those in Linux or on Windows if you use Hortonworks Data Platform. If you're more familiar with Linux, which I'm not a Linux guru, so I typically prefer to deploy on Windows, but a lot of folks are very good with Linux and would prefer to do that, and that's perfectly fine. You can do either one, or you can deploy an on-premise cluster. Again, like I mentioned, if the cloud truly isn't an option, then deploying on-prem is another viable option, although I will tell you it's not going to get you the on-demand and the scale that you're looking for. All right, so let's go build our own, shall we? So we're going to jump in. I added just this quick demo slide. We're going to build and deploy an on-demand cluster with HD Insight and PowerShell, and we're going to do that right now. So let me get my script screen set up here. I'm going to pause my screen sharing here for just 1 sec and close down this PowerPoint shenanigan. And we will get the script up and running. All right. Hopefully you guys can all see that. Hopefully it's not being cut off. I didn't change any other settings. So one of the things that we need to do first, before we go and worry about what we're going to deploy, is we need to log into our Azure account. And so you'll see I've logged into our PragmaticWorks Azure account here. And you'll see over here on the left, I can have websites and virtual machines and mobile services and SQL databases and all of these different things that Azure provides. Visual Studio, there's so many, machine learning, all kinds of things, right? The one I care about the most today is HD Insight. Well, I don't have any HD Insight clusters, so I have the option to just go through here and click a couple of things, fill in a few pieces of detail here, and bam, they will spin me up an HD Insight cluster that I can then connect into. That's too easy, right? I think we got some folks here who might think that's too easy. Now, if you don't want to approach the PowerShell, things that we're doing today, this will do exactly the same thing, except that you may want to do a custom create, so that when you get down here a couple steps later, if you want to use a SQL database as your metadata metastore, you can do that. Otherwise, the quick create, which we were just at, will just create you one with an internal metastore, which means when you get rid of the cluster, it's going to go away. All right. So I could do that. That would make a lot of sense. So I think what I'll do is I'll go ahead and say, we'll call this webinar cluster. I don't need 4 data nodes. I'll just do 1 data node, so it keeps it small. And I'll give it a password. You guys thought you were going to get my password, didn't you? No such luck. And I've got all these different storage accounts. And these are all being used for all sorts of different things. I'm just going to go ahead and put it in our Pragmatic Work storage account. So if I were to upload data, which I'm not going to do a lot of today, it would go into that storage account. And I can click Create, and it's going to go ahead out here and start creating this. Now, that'll take a few minutes, and I'm playing a little bit of Martha Stewart with you guys, so I apologize. I'm going to go ahead and let this one create while we go over and take a look at the script. And then I'll run the script, and you guys can see it's basically going to do the same thing. And while the second one is creating, we'll go explore this first one. Now, if you're wondering what's really happening, you'll notice I did some cleanup here earlier, so I've got some leftover messages. And it's creating my cluster webinar cluster. And it's submitted the job. The job's been accepted by the Azure Fabric, and so it's creating all the steps that it knows it needs to do to be able to go and create me an HD Insight cluster. Okay, so we'll come back and check on that in a minute. And in the meantime, we will, whoops, sorry guys, just clearing the questions out, trying to make sure nobody's too lost. All right, let's go over and take a look at the script, shall we? I made this font a little bit bigger in hopes that everybody could read it. I think I will make it just a touch bigger again, just to make sure. There we go. Let me know if you guys have any trouble reading that. And Liz, if we see questions on that they can't read the script, if you could just let me know and I'll make it a little bit bigger.
Absolutely.
Sure,
so
the first thing that we need to do, the very first thing, is we need to change our execution policy so that it's unrestricted, because I'm going to be running scripts, pre-built scripts. And that means that I need to be able to execute those scripts, and I don't want to be hounded and have to type in my credentials every time and all of that kind of stuff. Now, in order to run this command, you'll notice up here at the top, I have administrator in front of Windows PowerShell ISE. This is the built-in Windows PowerShell tool. I need to run it as an admin in order to run this execution policy command. Everything else that we're going to do today, you don't need to run as an admin, but for this particular one, you definitely need to have that in there. Now, for those of you who aren't familiar with PowerShell, this is essentially the place that I do most of my PowerShell development. There are other tools and other third-party vendors, but this one works pretty well for me. I can build scripts up here, and then I can execute them in pieces, very similar to Management Studio, if you want to think of it that way. Or I can come down here, and I can run through anything that I have outstanding. As far as in that directory, I can execute PowerShell directly from this command line, so I could say get, and I have IntelliSense, which is really nice. If you are wondering if you have the Azure PowerShell commandlets installed, the best way for me to find out is I just type get-az, and if none of these Azure things show up, you don't have it installed yet. All right, so go back and reinstall it. All right. So the first thing that we're going to do is we're going to go ahead and run this set execution policy statement. And it's going to say, hey, are you sure you want to do this? And I'm going to say, you know, I like to live on the edge, so yes, I'm going to change my execution policy. The next thing it's going to do is it's going to say get Azure publish settings file. Now, in order for me to connect my PowerShell environment up to my Azure account, it's really, really important that I have a certificate, right? I'm going to need something. And there's a couple of ways to do this. You can do it with a certificate. That's like a 4-step process that I really hate doing. Or we can do this Azure publish settings file. And that's going to be a lot more straightforward. So if I run this command, first thing it's going to do is it's going to take me out to Azure. And you'll notice it's going to ask me to download this publish settings file. I'm not going to download it because I've already done that. The next thing you need to do, once you have that file, is just run this command. Just point it at your publish settings file, whatever your name is. Typically, it's a long, complicated name with the name of your subscription in it and all that kind of stuff. I simplify it. I always just call it azure.publishsettings just to make my life easier. And I typically have a good sort of standard place that I put it for demos and things. And you'll notice that I do have it if we go to this directory, you'll notice that I've already moved it over into this config folder. So if I were to run that, it would just doesn't give you any response or anything. It just says you're good to go. All right. Once you have that in place, you're ready to go, and you can start typing and running commands against your Azure environment. All right. Now, don't be scared by this script. This script has a few sections, and we're going to take it section by section, and I'm going to show you first how we run it, and then I'm going to show you why it works. So first I'm going to go to my pre-con directory. If I could type today, we'll clear that red error out because that's embarrassing. And I'm going to say that little dot and slash is me telling the PowerShell window that I want to run a command. And I'm going to say scripts. And I'm going to say I really want to run this step 2 cluster build out .ps1. Okay? Now I'm going to go ahead and run that, and it's going to start outputting some stuff in the bottom of the screen, and we'll come back and take a look at that in a second. While that's running, then I'm going to walk you through the actual PowerShell script, and we'll show you what it's doing and how it's built. And again, by automating our creating of this cluster, that's what's giving us the ability to do all of the things we can do in Hadoop on demand, because we could literally spin this up at the beginning of a job. It takes a few minutes. The rest of the job will execute, and then with a couple of PowerShell commands, we can get rid of it all at the end, or just the pieces that we want to get rid of, like I mentioned before. All right, so you'll see it's importing values from a configuration file. It's got the values. It's creating a new storage account, blah, blah, blah. We'll go through all those error messages as part of reviewing the script. So the first thing we did was I said, you know, we've got a lot of variables and things that we need to pass in so that we can, you know, really give this script all the information that it needs to do its job. And so how did we do that? Well, let's go take a look. So in our config folder, I've got this deploy config file, and it opened on the wrong screen, so we'll move it over here. And this deploy config file has things like our installation region, our subscription name, if we need secondary storage, all of the different options that we might want when creating an HT Insight cluster. And by putting all of those in a config file, we have the ability to just import that config file and put it all into an XML variable here, and then we can reference it all the way down. So we can let the developer make all the decisions that they want to make up front, and we don't have to be prompted or any of that kind of stuff, right? Plus, with a config file, again, from an automation perspective, we can always change certain parts of the config file if we wanted to deploy in different regions at different parts of the day, et cetera, et cetera. So there's a lot of flexibility that really gives us, all right? So the first thing we need to understand is, do we need a new storage account? Well, we're starting from scratch, so I need a new storage account. And so we're going to go in, and we're going to create a new storage account. And we put some notes in here that say, you know, you've asked for a new storage account, so we're going to do that now. And again, all the magic is really here, right? So new-Azure storage account, give it a name, pass in the name from the config file and give it the location, and it's going to go out there and get that created. If we need a secondary storage account, which we don't, I said no in my config file because I'm a simple guy, I don't need 16 storage accounts, then it would go out and basically do the same thing. But since we're not going to do that, we can hide that, make this even simpler. We're going to pass in our Azure storage key and our Azure storage context, which is just an object that contains everything about our Azure storage account. And the reason for that is we're going to use that storage account later when we create our cluster. We're going to have to tell it, hey, Mr. New Cluster, I want you to use this storage account. And that's important because he's going to need to know where to go deploy. Now, within that storage account, we need a container. We need some place to put the data. Think of a container kind of like a folder, right? So we're going to come in here and say, creating our primary storage container. And you'll notice I threw some display hints for time in here. You'll see these down here at the bottom in the blue window because I want to make sure that as I run through these multiple times and I'm debugging them that I really understand how long each step is taking. So if there's a delay on creating the storage account or the cluster, maybe there's an Azure issue happening or there's something going on that I need to investigate. So those timestamps are just important to me. They go back to my days of being a DBA when I needed to have total control and understanding of everything. And they're just a good leftover for my OCD nature. We're going to again say new Azure storage container. Are you guys getting the hang of this? So we've got verb, noun. That's what we've got. So we're going to new storage container. We'll give it a name. Whoops. The name's coming right from our config file, which is pretty easy. The context of that, where we want to put that. Which storage account do we want to use? Well, it's this main storage context that we already created up here. And then once that's done, it'll say we're done creating storage components. Now let's work on the metastore. And if you remember, the metastore is that external database that we want to create that's going to store all of our metadata from our HD Insight environment. And that's really important because that's the piece we're going to probably leave once we get rid of the cluster. And because it's separate and just has a connection, that connection can be broken and reestablished as many times as we want. So you'll notice we come down here and we'll say begin metastore steps. So if in the config file we said yes, we need an external metastore, which I did because I don't want an internal metastore, then it's going to remind me that's what I asked for because I need to be reminded. Then it's going to come out and create a new Azure SQL database server using the information for the username and password we put in the config file. Or it's going to go get the one that we passed in. So we may have said, I already have a SQL database server out there. I'm fine. Just use that one. The next thing we need to do is really, really important. And this is the thing that will mess us up probably more than anything because there's very little documentation on it. So if I see you guys are mostly paying attention, this is the part you definitely want to pay attention to. Right here. So required or the HD Insight cluster won't be able to see the metastore and cluster creation will fail. That is incredibly important. In order to set up an external metastore, if you do this in the GUI in the Azure portal, there's a little checkbox that says allow all other Azure services to connect to this cluster. To connect to this database. And you check it and you move on with your life. It seems pretty easy. But in PowerShell, when you create that SQL DB server, there is no parameter for that checkbox. And so what that checkbox is doing is creating a firewall rule inside of Azure. And if you don't come in here and say new Azure SQL database firewall rule for that server and allow all Azure services, your cluster will try to connect when it creates. You'll tell it, hey, go to this server. I know it's there and it's good. It's going to try to connect and it's going to fail. Now, that would be not so bad if it said couldn't connect to Metastore as your error message, but it doesn't. It says task canceled. And that's all the message you get. And so a couple of us fought this for longer than I'd like to admit, along with some folks from Microsoft trying to figure out why that message was not giving us anything useful. And we figured it out finally. Actually, one of the folks on my team figured it out, Josh Ludeman. I got to give him big props. He's the one who figured it out. And now we add that in and everything works fine. So big important thing to make sure because you will not get a good error message on it. So now that we have a server and we can access it, we can go say new Azure SQL database. So remember, we're just creating a storage account, putting a container in that storage account for our cluster to use. We're creating a new Azure SQL database server. We're making it accessible to all of our services. And then we're going to create a new database to use as that metastore. Of course, it's going to take the database name and the server name from all of our previous variables. And then if we want to, we added the option for some of these other tools like Oozie and Hive. They like to have their own metastore sometimes if your design really needs that. Ours doesn't. We didn't say we needed that, so we said no thanks. And we decided to pass on that, so none of this code will actually run in this particular instance. Again, in our config file, if you go back to the config file, we just left the same database name in here for the metastore databases. So that way the script will just know, hey, just use the same database for both of them. All right. Now, the very next thing that we'll do is we just create a username and password object to give our cluster access to our SQL database. And from there, it's just a little bit of decision tree logic to be able to say, which type of cluster creation are we going to do? We did one with an external metastore, so we're going to create a cluster without secondary storage and including an external metastore, and that's this one right here. And so you'll notice we're going to say new Azure HD Insight cluster config, and then we're just going to fill out the options, pass the variables in from our config file, and because it's in a config file, we can change those at any time, and all the automation will still work. And then the very last thing that we pass in is a new Azure HD Insight cluster. We pass in our install region and the name we want for the cluster and the credentials. And that's it. It's pretty straightforward. It's relatively easy to automate. And if we take a look at what's happened down here, you'll see that once I ran the command, come on, there we go. It created a new Azure storage account. It created our primary storage container. It gives me all the information about the blob container. And then it's done creating our storage components, etc. Now it's going to create a new Azure SQL database server. It added this firewall rule for my server. It'll give you the specifics of the firewall rule right there. It'll spit those out. Now that we have a server and we can access it, let's work on creating that metastore database. So we went in and we created this metastore 2014 database. I just took the defaults. If you're worried about just having a ton of metadata, you may want to pass in a larger max size in gigabytes. But remember, this is just your metadata, not all of your quote-unquote big data or the data that you're going to store in HDFS. So now that we're done with all the prereqs, it's building the cluster. Excuse me, and it started at 11:47, and we started the other at 11:43. So it's been about 4 minutes. Usually the cluster will take anywhere from like 4 to 7 minutes to finish at the end. But let's pop back over to our Azure portal, and you can see that both of these are still creating the individual cluster. There must be something. Oh, yep, there we go. Page refreshed. So this one's should be operational here in a sec. And this one will probably run for a few minutes. What it's really doing under the covers is it's spinning up all of those Azure VMs that are all the nodes that I wanted, right? I may have forgotten to change in the config file. That may be the pre-con setting, which is a few more nodes than I would have liked. So that one may not finish while we're on the call today. But for this one in particular, we can go in and manage this cluster, and we can do a number of things. So we get a portal. Let's see. Uh-oh. Did I forget the username and password I put in for this? Let's try one. Oh, that's not very nice. Looks like there might be a little issue going on in Azure at the moment. So I may be having trouble managing that particular cluster. But if you notice over here, we've got our new storage account that got created. Actually, I used the PragmaticWorks storage account, so that one's still there. But if we look over at our SQL databases, you'll notice, if I refresh this page, I know our Metastore database is there because PowerShell already created it. They're right there. So you can see our Metastore database, and we can go connect to that if we want to. We can connect right to it with Management Studio even. So from an automation perspective, this is really very straightforward. And then the cluster's up. It's ready to run. I'm not sure why we can't access the other one, but it's giving me a weird error right now. But we do this kind of thing all the time internally and for our customers, and it's proven pretty reliable and pretty resilient. I have a feeling it says operational, but I still see those little ellipses moving, so I'm sure it's still doing some final configuration. I probably tried to get in there a little too early. So I hope this has been a pretty good explanation for you guys on sort of the basics of doing big data in the cloud. Good overview of how to automate it with PowerShell. I know we could spend a whole day on some of this stuff, and we do when we do the pre-con. But I wanted to do a webinar just to kind of give you guys a preview of the types of things that that we can do when we're really focused on trying to get value out of our data. So, Liz, I think we have time for just a couple of questions. I don't know what we have in there at the moment.
The only real question is they want to know if your presentation is available.
It's top secret. So yeah, we will make it available. Actually, if you guys want to go check out my blog, it's ajbigdata.com, and if you guys check it out there, I'll have something up there posted for you guys maybe by the end of the day.
And what we can also put a link to Adam's site on our blog site, so to make it easier.
Yeah. If you check out pragmaticworks.com, we'll have it there, and we'll link over to where you guys can download it directly.
Okay, we do have one question that just came through.
Sure.
Okay. Can you erase by accident real data and how to recover it?
So you can always accidentally erase real data. One of the nice things is Azure has new features called site recovery, so you can back up a lot of that data. In Azure Storage, you have geo-replicas of some of that data, so that gives you a lot of additional flexibility. So there are some options, but you still need to be aware of what you're running against and what data you're accessing, just like if you were in a production database.
Can you do the same thing in Amazon Cloud?
So Amazon's Cloud does have some similar functionality, but you can't do it with something as easy as PowerShell. Typically, you're writing custom Java code to be able to do this, and it's a lot more. I mean, you'll notice the script that I wrote that does all of that is what? I mean, and it's got all kinds of options. It's 150 lines. You're probably looking at maybe 1,000 lines of Java to do something similar. So unless you really, really love writing Java, ideally I would tell you it's possible, just not as accessible, certainly for new big data practitioners.
Who can see the data? What is the complexity of managing security of the data?
So you have the ability to manage the security of data at the container level. So if you set up the container as private, it would only be you. You would need to have the secure key to be able to access that data. You can only get that from inside the Azure portal. You can export that key and give it to somebody else. So from a security perspective, it's very secure. And the complexity of managing it is it's actually pretty minimal.
And that's all the questions we have.
Okay. All right, great. Well, everybody, thanks a lot for tuning in. Liz, did you have anything else you wanted to add?
Nope. Thanks again, everyone, and we'll make sure to get that blog post up on our site by the end of the week.
Great. Thanks, everybody. Have a great day.
Bye.